top corner of the screen, you see that little red dot? If you see me talking, not this class because it's obviously recording now, in other classes and that red dot's not there, tell me because I probably forgot to hit record. Okay. All right. Where is, nope. I lost my website.
Will you record because we will be able to go back and listen
Yes.
to the class. Thank you.
So I do not use Blackboard. The only thing you're going to see on Blackboard is your grades and the syllabus and the post that I've already put up there. So none of your assignments will be on Blackboard. I don't collect anything on Blackboard. Everything that I post will be posted on my website. The reason for this is I think my website's a lot easier to use than Blackboard, and you don't have to log into it or anything else, so you'll have access to it forever. And other students also have access to it, which is kind of nice. So you're going to go to my website. It's Baker's Math Class. It's linked in Blackboard as well. It's also on your syllabus. You're going to click on statistics, and you'll see the information there. So what you saw up to today was this one, and your syllabus and everything else is there, and a link to Hawks is there as well. I've already had my, I teach this class actually in the morning and at 11 o'clock and now. So I'm only going to have one post for each day because it's basically going to be the same thing. So I've already posted my information for my first class. You'll see the class notes posted there. So you can just click on it and it comes up with the exact notes and stuff that you'll be seeing in class. Anything that I write on the board will be saved that way there. So if you don't write everything down that's on the board, don't worry about it. You don't have to take pictures of it and stuff like that. You can download it afterwards. It's just a PDF. And as you can see, the video recording for my other class is already there. It's YouTube. It's unlisted on YouTube, so you're not going to be able to search it on YouTube. But any device that you can use YouTube on, you can click on that link and see the video. All right. I also add closed captioning on there too as well now, since I know a lot of you guys like to use closed captioning. Doesn't make sense to me, but it's okay. It is there as well. It's Google Translate that does it. So it might not be perfect, but it'll be close. All right. Any questions on that? Awesome. All right. So it's going to be a syllabus. Talk about that for a bit. I wasn't expecting a computer lab, so that's kind of nice. So I'll actually design some stuff to actually use the computers in front of you in class. So we'll actually do some of that stuff, which will be kind of nice. That also means that what I'll probably do is the tests will be actually using Hawks on the computer. You'll do them right in class. The nice thing is that means you'll get your results immediately back. The other nice thing is you will not need a calculator because I'll let you guys use a website to do most of the calculations. So you don't need a scientific calculator, graphic calculator, or anything else for this class. You'll use the computers. So save yourself a little bit of money there. I actually live in Hartford, so I only come down on Mondays and Wednesdays. So if you need help, I'm actually going to be here about 8:30 in the morning. Not in this room, but I'll be here from 8:30 until about 3:15 after this class, every Monday and Wednesday. So if you need help, you see me before class or whatnot, that's easy to do, or we can say a little bit after. If you want help on other times than that, just send me an email or a message or a text message, and we can set up a Zoom call or a Google Meet, and I can do that online. That's not a problem either. The email changed. I totally forgot to change it on here. It's now that ctstate.edu. That is my phone number. It goes right to my cell phone. If you need help or anything else, the fastest way to get a hold of me is text me. Just send me a text with the question, and I'll get back to you. I have been known to literally answer people while I've been sitting at hockey games and everything else. So if you have a question, feel free to text me. I'll get back to you pretty quickly. Email's a little hard unless it pops up on my phone, but text go right there. So simple enough. You should have the Discovering Statistics and Data Software. I think it's the only book that's available on the bookstore. You do not need the physical hard-covered book. If you have it, great. All you truly need is the code to get online to Hawks. Okay? So if you don't have that yet, that's okay. You can sign into Hawks today. It gives you 2 weeks free to get your codes and everything else because financial aid and stuff like that. After 2 weeks, you will have to put in your code to continue doing the work, though. Please make sure to get into Hawks as soon as possible. The work has already started to be there. Nothing was due up to this point, so no worries there. But the quicker you get in and make sure everything works, and if you have questions, just email me or message me, and I can get you help with that. All right, the thing that everybody's always worried about: how you're being graded. I will put all the grades in Blackboard, so you can keep track of your grades in Blackboard there. Don't use the Hawks grading because it'll be slightly off. It's not calculated exactly the same. 20% of your grade is the homework from Hawks. I think there's like 35 or so lessons or 40 something lessons, and I'm going to drop the 5 of them. So if you don't complete them all, that's fine. 20% of that is, and basically all the stuff on Hawks is mastery based. So I think you need to get 80% on your test to master it, and then you get a full 100%. So it's either done or not done in terms of your grade. So once you've mastered it, you're good. You can go on to the other ones. The homework and Hawks will say it's due before the test is. So all the stuff from chapters 1 through 4 will be due before we do the chapters 1 through 4 test. I am not going to put the final grade for the assignments in until the end of the semester. So even if it's late on Hawks, do it. You'll still get full credit for your homework. Okay, so you'll have until I think it's December 4th, right before the final exam is, to complete all the homework assignments, and then I will put the grade in, the final grade into Blackboard for that. Does that make sense?
No, wait, we still have to do the homework, but it's not due until December 4th?
So correct, the homework's there.
Oh,
So work on it, keep up with it, because if you don't keep up with it when you take the test, you're not going to understand really how to do the test. However, if you fall behind or something happens and everything else, that's fine. I'm not going to put the final grade in for the assignments until the end of the semester. So you can always go back and fill in those holes and things like that. Or if you didn't master one or one not, you can go fill those in. Life happens. I try to be fluid with that. It's like this way, people's like, oh, I need a couple extra days. It's fine. You have till the end of the semester. It just makes it easier in the end. And then I just pull the grade from Hawks at the end and put it right over there. And it's one thing and it's done. You do have 3 tests. Let me grab this syllabus. So the first test is on chapters 1 through 4. It'll be on October 2nd. All your tests are going to be on a Wednesday. I will review the test on that Monday. So we'll have a review on Monday, and then your test is on Wednesday. So the first test is on October 2nd. The second test is on October 30th. And the last test is on December 4th. And then the final exam, I don't know exactly when that's going to be yet. We haven't got this final exam schedule yet. So, but it'll be sometime between the 10th and the 16th. So I'm hoping it's the Wednesday, the first Wednesday, and not the 16th, but we'll just have to wait and see. The 3 tests are with 45% of your grade. So 15% each. The final exams were 25% of your grade. The one thing I will say with the final exam is, if your final exam grade is better than one of your test grades, I will replace your lowest test grade with your final exam. So say, for example, the first test, you just had a bad day, you did horrible, and you got a 60 on it. You get an 80 on your final exam, I'll replace the first test with the 80 for your final exam. Again, if you're going to do better on the final exam, you obviously know the material, so that's fine. So that's how so if you get a lower test grade, do better on the final, and that can improve that grade there. The opposite also works. If you get a 90 or above on all your tests, not an average of a 90 or above on all your tests. So if you get an 85, 100, and 100, this doesn't apply to you. You got to get above a 90 on all your tests. You are exempt from your final as long as you completed all the homework. So complete all the homework, get a 90 or above on all 3 of your tests. You do not have to take the final exam. Okay? Because same concept. If you did that well on all of them, you obviously know the stuff. You don't need to take the final exam. Participation's 10%. Basically, just show up to class on a regular basis. You're fine. I do not take attendance. So, no, I'm not going to miss you a bunch. But, I can easily tell if somebody just shows up for the 3 tests. So, that's where that 10% comes into play. So, just show up to class on a regular basis. You'll be fine. Any questions with any of that? Does it make sense? Okay. The only other one I know, somebody in my last class asked, we do not have class the week of Thanksgiving. Because I know a lot of people travel and everything else. That class, Wednesday's class was canceled anyway because the school's closed, and I just canceled the Monday class for that week. So we will not have class the week of Thanksgiving. So, all right. Any questions with the syllabus? Awesome. All right. What do you know about statistics? Yeah. I taught high school for 24 years or something like that. Nobody ever raised their hand. Just say something. Go ahead.
Statistics help you kind of, I wouldn't say assume, but kind of see like what would like say for business example of if there's more percentage of people coming in for a certain product and you might think like by this date it might increase or decrease.
Okay. Most business now uses a system called just-in-time inventory. That was why we ran out of toilet paper in 2020. Because again, they assume they have models. They use statistics to figure out, like, okay, I need to have this much stuff on these dates. This is how much I'm going to sell on a regular basis. And so their trucks will come in like the day or so before, and for that their inventory the next day. It's called just in time because they don't want to have to store all that material on site. So the entire supply chain works that way. So when we had that massive run on toilet paper in 2020, there was no way to replenish it quick enough for the system that we have. And they use statistics to do a lot of that stuff to determine that thing. So great use of statistics. What's another one?
A lot like psychology. I'm taking my Psych 101 class, and let me tell you, the wording and everything, it just overlaps everything.
Oh yeah. We used in my college. When I went to college, we actually had a class called Statistics for Psychology because it was literally you definitely need it. So there's tons of stats in psychology, and we're going to talk about the bell curve and stuff like that, and IQ and all that type of stuff. So
this is my afternoon from 2 until 5. My 2 classes.
Well, that works. It'll mirror each other. So lots of numbers, lots of information, but hopefully it'll fit together well, so it'll make sense. What's another? Yeah.
You should use statistics to see someone's performance on your own. Sports.
Yeah, absolutely. Sports use a ton of statistics. Data analytics in sports is huge now. They use sensors on everything. So it's like baseball's got the longest season, so there's tons of analytics and everything else. And actually, there was a whole movie called Moneyball that was basically specifically about using stats to determine the best team. Oakland did great until they got to the playoffs. And actually, that's part of the big difference in baseball compared to some other sports is baseball's such a long season that everything happens to go to the middle of the norm. So statistics can be used to model it quite well. When you have very short seasons, which what happens in the playoffs, you can go on runs. Football is another case. Very short season. There's only 17 games, right? I think there's actually 18 now. I can't remember. I know they changed it recently, or it went from 16 to 17. But it's a very short season, so you can go on runs in those where you don't have enough information to really go to that mean, where in the longer seasons you do. But they have sensors on the bats. They have sensors on the balls. They have sensors like in hockey on the pucks and on the players to measure their muscle tension and blood pressure and all this exertion to figure out how fast they have to pull players out. That's why if you like baseball back a long time ago, pitchers used to pitch the entire game and like come back 2 or 3 days later and pitch again. Now pitchers go 5 innings and they're pulled because we have so much data to show that after that innings, their performance starts to drop. So it's better to bring in another pitcher to actually bring up the performance to keep it at that high level. So yeah, sports use statistics all the time. What's another one? Yeah.
I know statistics, like not just in psychology, but all other kinds of academic fields, like all the academic papers and studies and all that stuff use a lot of different statistics and stuff.
All data.
Yeah.
They always have to collect the data and analyze it. When I went, I stopped, but when I started going for my doctorate, they said that the statistics class is the make or break point for most people. So it was crazy. Every degree I got, you had to take a statistics class. And in the doctorate program, they said that was the class that If you passed it, you were going to finish your doctorate. If you didn't pass it, you shouldn't get a doctorate anyway. And it's like most people and that doesn't matter which area you're in. It didn't matter if you're going to get your doctorate in English, you had to take a stats class because that's how important this is to study data and those research papers and everything else that you're having to do towards your doctorate. So, yeah, one of the things that I'm really hoping by the end of this class that you can do is you're not going to understand everything you read out of those papers just because the levels are so high, but to understand how they're collecting their data and how they come to their conclusions, that's important. Because what we've seen in society recently is that because data is becoming so much more important, so used, if you don't understand it, people can use it to manipulate you quite well, one way or the other. And being able to ask important questions about how did you get this, or what was your study, or who did you ask, or how did you do your sample, and those type of things will start to get you a lot more information, and it will force the people that are throwing out these numbers to start going, whoa, I have to actually understand this before I can say that, which is important. All right, we get so much of our data from memes and little videos and little quotes and stuff like that now, that understanding where that information is coming from and making sure that it's valid information is also very important. All right, one more. What's another place we can use statistics? Yeah.
Is it in like vaccine preparation and like testing it out and making sure that it's actually accurate?
Yeah, so vaccinations are one of the big things. Actually, so this goes to show where understanding how to do a study and getting information is important. So when they first started doing the COVID vaccine in 2020, and they were asking for people to volunteer to get the vaccine to figure out if it was effective and stuff like that, most of the studies that they had done came back that they said that the COVID vaccine was about a 90 to 95% effective, which was great. That's what, because that meant that herd immunity and everything else that they were talking about, that hit that level. When they started rolling it out to the mass public, we were only getting about 65 to 75% effectiveness out of it. And people were like, well, you lied. The data was wrong. The problem wasn't with the data. The problem was with how they did their study. When they did their studies, they asked for volunteers, which any medical study, you have to volunteer to do it. Problem was, who was most likely to volunteer for this study? Healthy people, people who were doing everything they could to stay healthy, which means they were masking, they were social distancing, they were using hand sanitizer, they were doing all this stuff to make sure that they were healthy. So when they were taking the vaccine, they, of course, were also going to not get COVID. When they rolled it out to the mass public, not everybody was doing that. So that showed when they took their sample wasn't very good in terms of that. They needed a wider variety of people to do that sample. That was what caused that massive drop in the effectiveness. It wasn't the vaccine, it was how they did the study. And that's where understanding how that stuff works means you can ask those questions and get that information, or being able to look at the study to be able to get that type of information back and be able to understand why those numbers are changing. And then when you understand the why, you have a little bit better understanding of how things can change, so that it's not that somebody's just lying to you about it. It's that new data came up and we have new information about how do things change. So that's where we're going to start to look at a lot of this stuff. Not today. Today we're going to do a lot of talking. But going on from chapter 2 and beyond, we're going to really start to look at a lot of that information. All right. Let's start. Actually, there was one more, and we didn't, and nobody said it. What's the big thing in the news today and all the way through November? Yeah. So we got politics going on. We're going to talk about it because it is the number one use of statistics right nowadays. Politicians use stats all the time, and I guarantee 90% of them have no clue what they're talking about. But they want to say they do. And when they're spewing numbers, they're using them to say a certain, their side of it. Okay. Every study and everything else you have always has a bias. You have to understand your bias and accept that. That's fine. But everything has a bias. So when you're looking at the hard data, when you do that analysis, that's where the bias comes into play. Numbers, there's no bias in numbers. It's in the analysis that we do afterwards that has that bias. The other thing you're going to see a ton of is polling data. So this is the latest polls. So nationwide, this has got Harris up by 2.8% right now. Okay. So they've surveyed the entire country and they're saying Harris is winning by 2.8%. Now that's the nationwide poll. And if you follow anything with politics, you know that the Electoral College is more than just the popular polls, but that's another story for another day. How many people do you think they asked? Do you think they asked everybody?
Like, like a certain amount of people per capita.
Okay. How many?
Like, I think it's like 16 or what's that?
16%? Or 16 people?
16 people. I don't know.
Okay. So out of the whole country, I only need to ask 16 people? Oh, from each like county and stuff? Okay. We're gonna pin in the 16 because you might be right. I'm just not quite sure yet. Just talking about right and wrong. If I ask a question and you give me an answer and I ask you why, don't assume you're wrong. I will ask why no matter what. Okay, so don't go when I ask why, I go, oh, never mind. It's like, no, tell me why. Like I because one of the things with statistics as compared to most other math classes, there's not always one right answer. Okay, in every other math class you've ever taken, there was one right answer. You followed a step procedure to get to that answer, and that was the answer. That is not true in statistics. Most of the time, you're going to do analysis, and there might be a variety of ways that you can answer that question. Okay, so if I ask why, it's because I really want to know why you said that. All right, not that you're wrong. All right, anybody else want to take a guess on how many people they would have to ask? Yeah.
I have one more thing to add on. It's not all like the same amount. Same amount. It's like depending on the populations of the different states.
Okay, so this one is a national one. So we're just forget the state ones; those are different. So we're going to look at the national one. So I want to know how many people they should have asked across the entire country to determine the national poll. How many people do you think would be good to ask that question to get a good idea of what the entire country thinks? That'd be about 200 million people. That'd be a lot of asking to do. And if it costs you a couple bucks per person, that's a lot of money you do. And they ask these polls probably every few days. Probably not going to be every person. Yeah. 100,000? Would you be happy with 100,000 people?
444,000.
444,000. Okay. He did some math to get that number. Anything else? All right, let's see. Oh, wrong one. This one. These are the numbers of how many people they asked. Right in the middle. So this first poll asked 1,386 people. The biggest poll here asked 7,818 people. But most are in the thousands. That's it. You actually, for most studies, that's about all you have to ask to find out the idea for the entire country. So they're asking a couple thousand people and then putting this poll out and saying that's what pretty much the entire country thinks. That's using statistics to do it. Okay. How do they ask those 2,000 people? Huh?
Is it random selection?
It is a random selection. But how do they pick? How do they actually talk to? How do they get the information from them? How do you think? Okay. Again, they ask these polls constantly, so sending things through the mail is probably not going to be the fastest way to do that. I don't think I've seen some through email. That's possible. So here's the problem with using like email or polls online and stuff like that is you don't get the variety that you should get. Okay, so when they email you or they put a poll online, Facebook, whatever else, the ones that are most likely to answer the questions like that are the ones that are on either end of the spectrum. They either really care or they really hate the other side. Like they're on either end of the spectrum that are going to answer. You don't get the middle very much. Okay. Believe it or not, most of these polls are done by phone. They call people. Okay. How many of you answer the phone if it's an unknown number? How many of you actually would listen to and answer the questions that they asked? They said, I'd like to ask you some questions. Okay. So what is the most underrepresented population in these studies? Millennials and Gen Z. Because you don't answer the phone. Okay? While trying to get a random sample, these polls and all this stuff, most things on these type of surveys tend to skew older. Okay? I used to say, basically, it's the old white ladies that are sitting in their house bored out of their minds that answer these polls. And it's probably pretty accurate because they're going to answer them. I will say, if somebody calls you, answer the poll because a ton of policy decisions are made based on this data. Okay? I know it sounds weird. I know it's crazy, but it's 5 minutes out of your time to answer the questions if they call you and ask. And hopefully when they call, it actually comes up with like poll or something like that other thing. Like if you say Quinnipiac poll, like answer the phone, like answer their questions. Because that means your information is your answers are being used to influence policy decisions. And if you think about it, if the people who are answering these questions and answering the polls are older, the policy decisions are going to go in the views of the older population, not in the population from 18 to 30. Okay? So things to keep in mind. But yeah, we don't need to ask that many people to get these things. And you got to think, do these polls influence decisions in terms of the general population? Yeah, when you constantly see Harris is up or Trump's up, whatever it is, you're going to feel that, okay, obviously that's the one who's going to whatever else. Okay? How many people are running for president this year? Anybody know? It's more than 2. It's actually closer to about 4,000. It literally takes you $7,000. You have to be 35 and a natural born citizen, and you can run for president. Now, you have no chance of winning. The vast majority of them have no chance of winning because the vast majority of them literally aren't even enough ballots to be there. But to actually sign up to run for president, that's all you need. There's 4 national candidates that are running that are actually on enough ballots to get 270 electoral votes. And most of you probably only know the 2. And these polls only ask about the 2. That influences opinion. If those are the only 2 options you're given, those are the only 2 options you think can win. Okay? So using data, they can influence outcomes. That's important to understand. All right. So when we're talking about statistics, let's start looking at some actual score in our definitions and stuff. Again, all this stuff will be posted online. Write things down that you need, but don't sit there and stress about writing every single thing that's down on the board down. Oh, I did forget one thing about the tests. On the tests, you are allowed a note card on your tests. 3x5, 4x6, a standard size note card.
Just one.
For both sides, handwritten, for your tests. So you can use it to write down some formulas you need to know, or like a definition of things. When I do the review, that's when you can make your note card up, because you'll see about what you're going to need to know for the actual test. We'll talk more about that when we get to the actual test in a couple weeks. All right. The first and most important thing you're talking about in statistics is the population. This is what you're studying. Okay, so in the things we were just talking about a minute ago, the population would be all the people of voting age in the United States. That would be our population. If I wanted to find out the ice cream preference of a Three Rivers student, my population would be Three Rivers students. Okay. So the population is the total set of things that we're interested in studying. If you can list them all, we call that the frame. You're not going to see that term used very often. However, Hawks might ask you it, so I make sure I put it in there just in case. But population is the most important one on the screen. What do we do every 10 years in the United States? Why is it important to take a census? Okay. Why do we care? Anybody know the population of the United States right now? No, those are voting age. Yeah. 333.3 million. At least according to Google. That was 2022. So it might be a little higher than that, but not 30 million higher. Actually, hold on. We'll use the population clock. 337 million. Now, this, as you can see, the world population is changing constantly. This is not a census. This is using statistics. Okay? So it doesn't know that, oh, somebody was born or somebody dies, and it changes this. It uses statistics based on what we know is happening. So, for example, right down the bottom here, it knows approximately every 8 seconds somebody's born. Approximately every 11 seconds somebody dies. So that allows them to use statistics to be able to decide how the population is changing. However, that's for the US, yeah. That's the US. However, if you click the world here, I don't know if it actually does it actually show. Nah, it doesn't show that concept for the world. However, the census is actually built into the Constitution. It's to decide the population for voting purposes. Because the population is tied to the number of electoral votes you get in each state, they need to know the population in each state to be able to determine that. That is why it's required every 10 years. It used to be that we had 7 representatives in the state of Connecticut. We now have 5. Because our population didn't decline, our population is constantly growing, but it's not growing as fast as the other states. So we lost some representatives, which in essence lowered our electoral votes. So we now only have 7 electoral votes instead of 9 that we used to have. Okay. The electoral votes are based on 435 for the House of Representatives and 100 for the Senate. That's where they get the 535 votes from. You need 270 to win. Or it's 269 something like that. 270. When the Constitution was written and the first censuses were taken, the number of representatives was based exactly on the population. So it was approximately every 30,000 people had a representative. So for a while there, that would change. It would go up slightly. I think it ended up being around 100,000 people per representative in the House of Representatives. I believe it was 1912, and I really should have looked it up between classes, but I didn't. At some point in the early 1900s, the Congress decided that they were going to cap the House of Representatives at 435 people instead of allowing it to grow with the population. That's what's caused our electoral college issue today. Because now, in different states, those representatives are representing more people or less people. In the state of Connecticut, we have 5 representatives, and we have 600,000, or just about 650,000 people per representative, because we're just over 3 million people. Wyoming has 570,000 people. They have 1 representative. So technically, that representative represents less people than our representatives here. If it was based on the exact population, we would have a House of Representatives probably around 2,000 people right now, which would cause even more chaos in Washington, but it'd be fairer in terms of the Electoral College. So that's how they started using statistics to be able to change that population and decide those type of things. That's where the census comes in. That's why we do it every 10 years. It cost us $13.5 billion to do it in 2020. So, which in the grand scheme of things is nothing, but sounds like a lot of money. All right, so a census surveys all information. Okay, so in 2020, either you filled out your census or your parents filled out your census, and because it's based on household. In that, it finds out information about how many people are in the country. It finds out different ethnic groups, different genders and sexual orientations. It finds out ethnicity and race. It figures out salary information. All that stuff is there. All the demographic information that you could possibly want is collected by the census. It is not tied to an individual. It is then aggregated so you can use that information to determine things. The census has to include everybody. So they send people, if you don't fill out the form, they send people out to your house. And they knock on your door and ask you questions. They send people through homeless shelters and homeless encampments to make sure that they get counted. Even illegal immigrants that are in the country get counted as part of the census. That is important for us to know that, have that information. They're underrepresented because they're leery of anybody from the government asking them questions, but they're supposed to be counted as well. So that's how we get our information that then is used to determine a ton of things, especially money. More population, more money comes to your state. So when the census comes around in a couple of years, make sure to fill it out correctly. It literally just finished. They finally finished. The final report for the census came out in August of this year. So it takes them like 4 years to actually go through, do all the analysis and everything else. And 6 years from now, we'll do it again. They actually want to change it. They actually want to get rid of the census and just do it based on statistics, but there's a huge fight about that because the statistics aren't completely accurate. And as time goes on, those statistics will get a little more muddier. So by having that census data every 10 years, we actually can readjust our information and make the statistic models even better. But when you're collecting your data and you're doing your things, we have specific parameters that we're looking at. This is the piece of the information that you're studying. Okay, so when I talked about Three Rivers, we were talking about ice cream flavor. That would be the population parameter. The ice cream flavor, your favorite ice cream flavor. The census does a ton of them. Most studies do not do that many of them. They'll look at a very specific set of parameters about that population that they're looking at. All right, so we've already determined that we cannot. It would help if I actually switched over to this. If I'm talking about a bunch of stuff and it's not on the screen, just tell me. I have to actually make sure I share the tab that I'm looking at. So sometimes I'm looking at a different screen than you are. All right, we've already determined that we cannot ask every single person in the entire country information because it costs a lot of money and a lot of time. And studies need to be done faster than that. So we need to collect. Skip that one. I already talked about that one. We need to collect a sample. If I was to take you guys right here and ask you your favorite ice cream and you told me, could I use that sample to determine what the entire population of the Three Rivers is? Why?
No.
Well, there's about 30 of you in here.
Crazy.
The convenience sample. Depending on how accurate I want, we're gonna do some calculations later on in the semester where you actually figure out exactly how many people you need to ask to get the accuracy you want. But once you get past about 30, they're actually pretty decent samples. However, the problem with this using this classroom isn't size. It's not random. Okay. When you're collecting a sample, it should be random. Sample does not have to be random. Notice there's nothing in here that says random. However, if you want to use that to talk about a population in general, you want it to be random. So a sample is just a subset of the population used to gain insight about the population. Okay. So you can collect your samples any different ways. How you collect your sample can impact your data, however. We have our population, which were described by those parameters. Those are the things that we're looking at in terms of a population. When we're looking at in terms of a sample, we call them statistics, which is where statistics came from. So a statistic is a characteristic about that sample. So these are the pieces of information that we're collecting. Also, I don't mind answering questions. So if you have a question or something doesn't seem right or whatever else, or I say something you don't understand it, just interrupt me and ask me. It's fine. All right. We'll use the nursing problem because probably a good chunk of you are in the nursing program because all the nurses now have to take statistics.
All
right.
What was that little side thing for the?
Oh, it was population parameter. I can make it bigger.
Describe by parameters. Okay.
And then samples described by statistics. So, okay.
Thank you.
No worries. All right, read the question or read the information. It's not really a question. All right, what's the population that this nurse is studying? All boys?
No, between ages 0 and 18.
Right. So boys up to the age of 18. It is important when you're stating your population that you're stating it precisely. So males or boys is different than 0 to 8, boys 0 to 18, because after 18 things do happen as well, and they're not looking at that information. So it is important to be precise with your populations. What's the characteristic of the population being measured? So what's the parameter?
Height.
Height. So that's all she cares about in this case is height. What's the sample? Yes. She collected 1,000. She looked at a sample of 1,000 boys. And they made sure that they were randomly selected. And they were those same 1,000 were looked at over time. This is actually known as a longitudinal study, where you're looking at the same sample over time to see how things change. All right. Is the purpose of this data collection to perform a descriptive or an inferential statistics? We have not talked about this yet. What do you
was the
think?
question again?
When she's collecting this information, is she using it to be descriptive or inferential? Okay. Why?
Because she's explaining what she's doing, what, like the height and at what age and how many, and if like it's boys. And
Okay. Okay. Who else?
It could be like a pattern of growth, like height growth of it could be like,
Okay, so is it descriptive or inferential?
differential,
Inferential. Okay, why?
because they're looking at the person over time to see if the boys that are in the 18-year-old boys are in a consistent or similar height
Okay.
in that range of time.
Okay. Anybody else?
So another thing too, in the descriptive, you can like chart it.
Okay. All right. Descriptive statistics is a collection, organization, or analysis and presentation of data. We're describing something. Inferential. The objective of the inferential statistics is to make reasonable guesses about a population characteristics using sample data. We're inferring something. Okay? So what was the goal of her study? No, that's what she did. She studied 1,000 samples, 1,000 boys in a sample and their heights. Was her goal just about those 1,000 boys, or was her goal about all boys from 0 to 18? Her goal was to study the population of all boys from 0 to 18. She looked at a sample of 1,000 of them. If she was just showing you the information from those 1,000 boys and their data, that would be descriptive, because she is collecting the data and going to present it using graphs and those type of things. That's descriptive. If she's taking that data and then going to infer things about all boys to determine what percentile you would fall into, that's inferential. Okay, so she's taking that 1,000 boys that she studied, and then the doctor is going to then use it on you and go, okay, you fall into this group because of the study that was done. Okay. We're talking, if you've ever gone into a doctor's office, and the ones that are younger, when you go, if you're still going to like a pediatrician and stuff like that, you look on the walls, you're going to see these charts. That'll tell you what percentile you're in based on your height and your weight and stuff like that. It's the only time, so if you ever have, when you have a child, it's the only time you never want your child to be an A. You never want your child to be in the 90, 95th, 90, like 99th percentile, because that means they're bigger than they should be. You want them to be 50, because that means they're average. Okay, but do you know how many? Like my girlfriend's a nurse, and she tells people, "Yep, your child's in the 57th percentile." What? That's wrong. It's like they're mad because we're so used to numbers, percentages. You want to be as close to 100 as you can. Not in this situation. Okay, so but that's how we use inferential statistics. Those are inferring. That data was collected based on a study, a sample, and then we're using that to infer information about the population, where you should fall in that group. Okay? And we use a lot of stuff to figure these things out. Anybody know the height of the doors?
34 inches.
The height of the door?
Yeah.
I guarantee you're taller than 34 inches. They're 80 inches tall. Why? Well, way more than the average person, shorter than that. The average height of a male in the United States is 5'10", which would be 70 inches tall. 80 inches is actually 3 standard deviations beyond that point. So it's actually 1 out of 1,000 people would have to duck their head to get through it. So that's inferential statistics. They know the average, and they've set standards based on that. Okay. We live in Connecticut. We live in New England. Have you ever been into a really old house and tried to walk up their stairs? They're really small and really tall. Okay. For a variety, they're really small because their feet were smaller back then. They're really short because their feet were smaller. They're tall because they needed to get into a very small space to go up. But that's literally why the stairs are so small, is because their feet were smaller. We've grown. You try to walk up the stairs, you're probably going to trip. Our body is so standardized now to the 11-inch by 7-inch high that you just know it by most, like literally your motor skills just know it. If it's off by even a half an inch, you will trip, because your body knows exactly how much you have to lift your foot up to walk upstairs without even thinking. It's exact. Oh yeah. I used to teach at Grasso Tech. It's like, yep, it's a very specific code. They have to be done exactly like that. Otherwise, you will trip.
You have to bring in on the whole houses, you have to bring in your furniture so that it can go on the second floor.
Yeah, because there's the doors are skinnier and yep. So that's how, even back then, they used statistics and the data to design these things to fit the people of that time. So I learned something when I talk about stairs. You know the spiral staircases? So in castles, they always have these spiral staircases. The reason isn't that they didn't have the room to put anything else. So there's a few reasons. One, the stairs are always different sizes, so you had to think walking up them. Otherwise, you'd kill yourself. The second one is it was always going in a specific direction. So because most people are right-handed, they had to hold their sword in their left hand, which means they were less effective with their swords. And since they had to think going up the stairs, it'd be easier for the people to fall down. So therefore, that staircase was literally a defensive structure in the castle. So that's the thing. Is like we don't think about a lot of these things, but all this stuff was thought about when we were building stuff. There's very specific reasons for everything. It's not just random. It's like those are the reasons. So kind of cool when I learned. I'm like, that's interesting. I never would have thought of that. But yeah, that's why they always turn to the right. So this way, you had to hold the sword in the left hand. So left-handed swordsmen were much better in battle. All right. Actually, I want to do one more question before I do this one. There's my mouse pointer. Every so often, my mouse sticks. Let's do this one. I know. I'm copying the question. I'm going to put the question. That's why it's up here. But thank you. That's what. Sometimes I need that. All right. All right. Here's our question. If anybody's really good at math, that's the job you want. You want an actuarial job. They make so much money. All right, what's the population?
Automobile accident.
Okay, why is it 50 automobile accident claims? Why is that the population? Okay, so if you randomly selected that, is that the population or is that the sample? That's the sample. So remember, the sample is a small portion of the population. So what's the population? Yeah. Automobile accident claims in the last year. That's the population. So the population is all the automobile accident claims from this company in the past year. He randomly selected 50 of them. So that is the sample. What's the characteristic being measured? Right. In essence, all he cares about is the region in this situation, right? That's the data he's collecting. That is the parameter, yes. And then the reason for the sample would be the statistic. All right. Is this data collection descriptive or inferential? Why?
Because he is using the 50 samples to take a guess at what the whole population of all the claims are by region. Like, however many of these 50 are from the east, then that same percentage of the whole, all of the claims must be.
Okay. Where in the statement did he say anything about finding the percentages?
Well, I'm using it as an example.
Okay.
He's summarizing the whole every claim by using those 50.
Yeah, he says he summarizes the counts by region.
Right. So this is where very specific wording is important. This is where wording and honestly, this is going to be the hardest part of this class for most people. If you're really good in math, really good in algebra and stuff like that, you're going to struggle in some situations with this. Okay? If you're not good in math, but you're good in English and stuff believe it or not, English is going to help you more in this class than the math side of it is. The math side I can fix. The wording is very, very important.
Is that what the wording is from?
So the nice thing about these are not like this situation. It's not a word problem where they're saying, okay, we want a specific answer out. It's actually how the words are written that's the important piece. And that's where that English and understanding that piece comes into play. So the key thing is he summarizes the counts in each region and gives that chart. Nowhere does it say that he's using that to determine percentages or anything else. You're inferring that he does that, but it not says that. So the way this is worded, this is descriptive. He's taking those 50, he's going to make a chart to show his boss, here's the sample of 50 I did, and here's what I see. The boss is probably going to use it to do a bunch of other stuff, but he's just giving the data to the boss about those 50 samples. So you're right. And that's where a lot of times in this class, you're not always necessarily going to have one right answer, especially the way that it's worded. So the way you thought about it isn't wrong. It's totally not wrong because that's probably what's going to happen in this situation. Just the way that it's worded isn't saying that he's actually doing that. So.
Descriptive is how the data is presented, and inferential is using that presentation to
make other determinations.
Okay.
Exactly. So, like, if they then say after this, they say they're going to use or using this data, they're going to determine insurance rates in the regions. That would be then inferring because they're going to take this data and then use that to infer what's happening in the region, which is going to create the insurance rates, which they go through the roof like they did here and everywhere else. You know. There once was a time where there was no seatbelts in cars.
And I remember when a child seat was metal.
Yep. I remember when we were just thrown in the back. We were just thrown in the back of the wagon. I was like, go play. Yeah, I was like, just go play, have fun. Okay. All right. So in a study, seatbelts were found to have 20% fewer fatalities than those who do not wear seatbelts. Do these results prove that seatbelts reduce the chances of a fatality? Why? Huh? Well, yes. It doesn't say that is going to eliminate fatalities, to reduce the chance of fatalities. So yes, there still can be deaths. All right. This perfect meme fodder. This is the type of stuff you see in a meme, right? It's just a specific, it's just a percentage and it says something underneath it. That's it. No, it's just in the study, seatbelt users. So they did a study of the population. They looked at people who wore a seatbelt in an accident versus people who didn't wear a seatbelt in an accident, found 20% fewer fatalities. Honestly, the number could be completely made up. I honestly don't know the number off the top of my head recently, but so this leads me to my next slide. Whenever you see something like that, you want to start asking questions. Okay. From the data they gave me, I don't know. What's the wonderful meme that says 90% of statistics are completely made up? Okay. I don't know where they got that number. It could be from an actual study. It might not be. I don't know. You want to ask questions. Okay. Just like going into an auto shop, like if you look like you know absolutely nothing, they can rip you off easily. Ask some really basic questions and stuff like that. They think you know what you're talking about, and they're less likely to rip you off. Same thing with statistics and math. If you ask right questions and get the person that you're talking to is either going to go, I don't know, in which case, ignore what they just said, because it's probably not true, or they just made it up. If they have come back with you with information, that's good, because that means you're getting more stuff out of it. So the first question you always want to ask, where'd you get the data? Where's this from? What's your source? That's important, okay? So you can go back and look at the sources and look at that information. So this is I was stuck at home doing nothing during COVID. This was my favorite pastime during COVID, I was reading those actual studies. So like when I was debating stupid people online that had no clue what they were talking about, I actually had the actual data. It was quite fun. We had to have some kind of enjoyment during that time. So you want to understand where the data came from. You want to understand what they did with it. What was sampled? How did they pick their sample? Was it random? Was it just a convenient sample where they was picking who they got? Okay. Was their sample very wide enough, or was it large enough to look at? Okay. Did they look? So there was a big thing when the vaccines first came out. Can a pregnant woman take it? Does it protect the fetus? They didn't have enough data on pregnant women taking, because pregnant women didn't want to take the vaccine in the trials. So that sample wasn't large enough to be able to use. So they couldn't actually say that it was safe or effective for that group. Okay. And then when they started saying it was, they had a very small sample of people that did it. So that's the type of things. Where did the sample come from? Did they get the information? How reliable or accurate were the measures used? Okay. So when they're doing that whole study, typically the very beginning of the study, they give you an abstract of what the study is. That's where they'll tell you some basic information. The very first couple paragraphs of the study will typically tell you how they picked their sample, what they did, and what they were studying. And then the end gives you the results. You don't need to read everything in between. Like reading just those will give you tons of information about that study. Okay. Are the reported statistics appropriate for this kind of data? So when you're looking at the information, were they looking at the proper statistics or to find those parameters? Did they pick the right stuff to talk about? So when we were talking about that COVID study earlier, and I said, well, they did the stuff on the vaccines, they didn't ask anybody, are you wearing a mask 24 hours a day? Are you using hand sanitizer every time you go out? Are you social distance? They didn't ask those questions. So they didn't have that data that could have been very useful to determine efficacy. So were they getting the right information from people? The probabilistic statement, this is where they actually take the information, create the probability statement. How is it calculated? How did they do that information? That's getting a lot more complex and more numerical, and we're going to figure that stuff out a little bit down the line so you can understand that as well. Do the claims make sense? This is the eye test. Does what you said make sense? Like the example we just did with the seatbelts. Does it make sense that seatbelts reduce fatalities? Yeah. You don't get thrown from the car as easily, you know? Yes, it probably does reduce things. If you had somebody saying the exact opposite, the claim just doesn't make sense. It's like, I would want to see your information on how that you're stating that is true. Okay. Should there be additional information? Do we need to do more studies? Do we need to look at more information? Do we need to look at it from a different perspective? And that's where the alternate interpretations come in. Every study that's published in an actual medical journal or any type of journal is peer reviewed. Multiple people have looked at this. Multiple people probably have done the study to make sure that the results are accurate before it's published. So looking at it from different perspectives is also very important for your things. So while the statement that was there in this question is a statement, and this is what we hear quite often, where's the rest of the data for it? How did you get that? How did you figure that stuff out? Okay. So hopefully over the next 16 weeks, you'll start to look at memes and go, where did they get that number from? Like, why are they saying that? Like, ask those questions. And that's what I want you to get. That's the big thing I want you to get out of this class. If you get that out of this class, we're gold. Yes, we're going to do a bunch of math, but that's the important piece, to be a little bit more critical thinkers about when people start saying things, where they came from, including me. Question me on anything you want. It's fine. All right. That's it. I will see you on Monday.